kind of a brand new talk. It's the first time that we're giving it together. Ceci spoke about Kotlin and Swift before, but we're aiming for this agenda. So we're going to share a little bit about the motivation. By the way, I walk a lot. I hope I don't get anyone dizzy. We're going to share a little bit about the motivation. We are quite curious. I think many people working in tech share this curiosity. So we're kind of mad scientists at heart. So we designed an experiment. Of course, it's an app. Quite simple app, but it's an app. We're going to share about those details, what we found during this experiment, and we're going to finish with a couple of ideas worth sharing. Hopefully, we'll get like 30 seconds for questions, but let's see how it goes. So let's join us in our DeLorean. Buckle up, because we're about to speed up to 88 miles per hour and travel a couple of years back in time. Back in 2010, I was the co-founder of a small development studio in Guatemala. I think we were the first one doing mobile in Guatemala or in Central America. And of course, that wasn't our first idea. We started as a startup with a product that didn't work. So we pivot, didn't work, pivot, and eventually we ended up doing mobile. My co-founder chose the iOS path, and I went with Android. And it's funny, because I was fresh out of business school. I was the one with a business background, minor in marketing. So picture me fresh out of the classroom trying to sell something to people that wasn't aware that mobile was a thing. So there were many challenges during the way, and mostly because I was doing both development and also trying to sell our apps. I noticed that the clients were looking to have some mobile presence, but not invest that much of their budget. So it was like this bargaining and negotiating over different terms in order for something to be meaningful for both of us. Elemental Geeks was my company. We were developing, and also the client, we were lucky enough to land several big clients. But on the business side of things, they wanted iOS first. Remember 2010, so Windows Phone was a thing. Most of the people deciding were using BlackBerry, so we were aiming for several platforms. On the other side, on the tech side, it was a big challenge to decide like a common architecture. Many of our developers, we were a small team of around 12 people, were deciding where they wanted to aim their career. So many of them didn't want to work on BlackBerry or Windows Phone. So it was a challenge on many different ways.
So since we travel back in time, let's start with where I started. I also started working at a small startup. And one of the challenges that we constantly have is that we have really small teams that were highly specialized in one specific platform. So whenever one left, it was really hard to say, okay, let's move one developer from the Android side to the iOS side, and let's make this project keep working. It was really hard to do that, and it was almost impossible because developers had a preference for a specific platform, or because they didn't have experience with the other language. So it's really hard to be able to move people from one team to another one. Well, back on that time, we used to use Objective-C and Java, so there were completely different languages, and that movement was really hard. And as time passed by, I also moved from company to a bigger one. We had a larger team, and we also kept having kind of like the same problem. When I started at this company, I started as an Android software engineer, since that was my main experience. And I constantly heard that if you look at the higher level, both platforms should have kind of like the same functionality and the same implementation. But for me, it was really kind of like distant, because I only knew Android, and iOS seemed like they had really particular things on how they did things. So it was really strange for me. But then they actually gave me a chance to move to the iOS side to experiment a little bit in there. And when I did that shift, it was at first a little hard, because coming from an Android world, I was accustomed to use object-oriented programming, and there were a lot of things that I used to do in Android that on iOS were maybe completely different, like using map, filters, and protocol-oriented programming and functional programming. So that was really kind of like, what am I doing here? But right now, after a few years, with Kotlin on the door and Swift more mature, then I see more the first comment that they told me, like, both platforms at the end zone are very similar, and there are just minor differences whenever you do an implementation in Android and on iOS. So it's easier to move one team from one team to another one. So throughout all of our mobile experience, we have seen how mobile has been evolving. Like I said, at first, Objective-C and Java were completely different and really hard to move from one place to another one. But right now, Kotlin and Swift make it a little bit easier. So Google, at first we were a little skeptical about Kotlin because it wasn't kind of like a first language on Android. But when Google launched, said that Kotlin was the first language on Android platform, then we started to see all of the possibilities that we could do. So we decided to do a little experiment and check if it was really possible for two people who work on different platforms to do kind of like both platforms at the same time. So we started to establish what was the experiment. We needed to determine what were the ingredients of our experiment and, well, okay, what could go wrong? We had some things in mind. First, we needed to establish what we needed to build. So we decided to have something that was simple and that was easily understandable. We didn't want to have kind of like a big application with a lot of use cases. We wanted to have something that was easily explainable. We also wanted to go out of our comfort zones. At the end, we both work on a specific platform each day, and we wanted to do something different. So we decided that we will probably mix it up, use some new technologies that we hadn't used before, and see how it went. And we wanted to have something that we could share it afterwards. So let's continue.
So it was something like this. I was like staring at Xcode, then staring at Ceci, Xcode, Ceci. I wasn't wiggling my tail, but anyway, it was a tough challenge, mostly because we're not used to using the other tools, both the language and the platform. We cheated a little in terms of having some previous experience. As Ceci mentioned, she was an Android developer doing Android full-time for a couple of years. I work a little bit on iOS, mostly on Objective-C, mostly because when you are a founder, one day you are a code monkey, the next one you are making coffee for everyone at the office. So we had several challenges doing this. We're aiming to build like this beautiful Jenga tower with the pieces right in place, so if at some point in the future we had to carefully remove one of those, this wasn't supposed to be any issue at all. But as we all know, in software that doesn't happen. So there were many challenges in the way. Luckily for us, things worked out. It was a really simple app. We're going to see it in a minute. But otherwise, we wouldn't be here, or we would be like doing magic tricks or juggling balls or rambling about Jenga. Anyway, so we love dogs. Those are my one-year-old puppies. Manchester Baron von Pufendorf on the left and Seymour Tebaldo Schumpeter, the greatest names ever, Chesito and Toby. So because we love dogs, we decided to go with a dog app.
So to build our experiment, we started to look at different APIs that were out there because we were not going to try to make our own API for this dog. And we tried to see what APIs were out there. We saw movies, superheroes, Star Wars, a lot of APIs. But since we love dogs, we found this great API that's called the Dog API. The data structure of this API isn't as complicated. It's pretty simple. You just return strings of URLs of dogs, and you could ask some random images, and you could specify the amount of random images that you want. You also have kind of like the breed list if you wanted to do something with it, but we just chose this endpoint. That's get random images, and we specified the amount of images that we wanted. So the UI is in Polish because we didn't get to that part. But this is on the right or on the left for you. It's the Android application, and on the other side, it's the iOS application. The idea of the application was a simple game that you could, we will show you some images of dogs, and you had to guess the breed that was on the top. So if you see on the iOS side, we wanted to guess what was the shipper key, and obviously I don't know which one it is. While doing this app, I figured like, yes, I love dogs, but I actually cannot identify any breed of the dog. It had also another screen that was the scores. So after several kind of like rounds, you get to store the scores on some local data source. When we started to do this experiment, we tried to discuss what was the best approach to discuss about the similarities and difference between both platforms. And you could look at it in different angles. You could look at it in terms of the language, if they have similarities or difference in each one of them. You could look at them in terms of the platform, like what elements are similar, like, I don't know, view controllers and fragments, or core data and SQLite. And you could also try to achieve it through how you structure your app in the different layers. So we saw that on the most upper level, that's the UI. We wanted to keep that really specific per platform, because we know that iOS has some specific ways of doing things like table views and how you register cells, and Android also has some specific ways of how you build the UI using XMLs and some sort of binding. So we didn't want to mess with that layer. We also try to avoid the lowest layers. For example, the remote service, we know that each platform has its own preferences on what libraries or elements to use in order to implement that. So we said we were not going to focus on that. But we said that we were going to try to focus on trying to have some shared approach in terms of the middle layers, the ones from the view controller to the lowest layers. That were the layers that we tried to make it similar.
So many decisions at this point. When you work at a medium to big company, there are many of these decisions already taken care of. Or maybe if you are like in the development team, there's a tech lead or engineering manager, or there are many other roles to consider when taking the decisions. We're just two, so it was supposed to be easy. But when you're working at a small startup, this happens quite often when deciding. So we're looking for something that at some level made sense in both platforms without reinventing the wheel. So we went with MVVM with an implementation of clean architecture, something similar to this diagram. There were two things that we were looking forward to grab from the API and store in our local storage. So we have a remote service for grabbing the URLs from the dog API. We use Retrofit and Alamofire on these two platforms. And for the scores, we used a local data service. Because it was really simple, we ended up going with a dictionary, shared preferences, and user defaults in the platforms. Then there's the repository. Funny thing, when I was doing a little bit of research for this, I'm used to using the repository pattern. For some reason, when looking at iOS samples, there were almost no mentions about repository, and there were many use cases or interactors. Because this was really quite straightforward, we decided on not adding another layer of interactors or one per use case. And we'll have the repository communicating with the view model that's doing a binding with the view using live data in Android and a manual binding in iOS. And the communication in the lower layers in Android is built using Kotlin coroutines and using closures and delegates on iOS. So basically, we built this from the ground up, thinking on looking for similarities. And even before started coding, we, like an educated guess, we noticed that the similarities might be here, like in the data layer, instead of here. Especially the layout is completely different. So among the way, we found some similarities and some differences.
Yeah, it's usually very interesting to try to see the similarities and difference between things, people, and everything around life. So for example, Adrian and me, we both like berries. I like more raspberries and he likes more blueberries.
True that.
So even though we both like both, we have some sort of preference from one to another one. So during this experiment, we wanted also to try to find those differences. Maybe I like more a little bit of Android things. Maybe I like some things that were more specifically to Swift. But that was our goal, to find like similarities between both of the languages. So when we did the experiment, we found some obvious lookalikes. For example, how we define variables. We both have like var and val and let and var. Depending on the platform that you're using, we both have optionals. Well, it's not called optionals in Kotlin, but at the end, they serve as the same purpose to guarantee the node safety. The way we define control flow, it's also pretty similar. So we can easily understand the other platform in terms of control flow, how we define variables. In terms of collections, we both have a functional approach. So collections tend to see pretty similar. So for example, here we have a method where we have an array and we try to convert it to a string, removing all of the nulls. So on the top, we have the iOS function. And as you see, we can use the flat map to remove all of the nulls from that array. And then we joined using a separator that's a space. And in Kotlin, it seems pretty similar. The only difference maybe it's the name of the function that we use to remove the nulls and how we join the strings, but you can easily understand like what's happening in both platforms by just looking at how we define these both methods. Another thing that's pretty similar that's usual is doing typecasting. In Kotlin, you have the operator that is to determine what type is a specific object or thing. And in iOS, you also have this operator. Even though it's not in the slide, iOS also has that operator. Also, both platforms have the as operator that lets you cast from one type to another one. You should always use kind of like the question mark in order to guarantee a safe cast. Otherwise, you might have a casting error in Kotlin and in Swift. You can use it as long as you are really 100% sure that that's the type that you're going to get. Another thing that's really common in both languages, and it's really used a lot, at least in the iOS side, is generics. Generics is not something new. Generics is something that started around 1970s, and it has been widely used by many languages like Ada, Pascal, C++, Java, and many other languages. So it's not something new, but it's really powerful because you create an implementation that's independent of the type that you're doing. So that allows you to do reusable code. Reusable code node in a sense that, let's say you have 3 implementations in 3 different files, and then you put it in one only file that you reuse in all of the other implementations. In this case, it's really code that's independent of the type. So you focus more on the implementation. The power of generics comes from decoupling the type from the implementation. So it's implementation independent of the type. I'm going to talk one specific use case that we use on iOS. In iOS, in the UI, we tend to have like a lot of boilerplate, and we repeat a lot of things whenever we're trying to handle table views, collection views, and a lot of things. And there's a big trend to use generics in order to simplify that part of the code. So for example, here, whenever we want to use a table view cell in iOS, we need to define those 2 lines at the top. So imagine if you have many cells, then you will have many lines there. And instead of that, by using generics, we're able to reduce it to just 1 line of code. So that's one specific use case for iOS for generics.
Keep in mind that we were trying to achieve these similarities, and we were switching between platforms and helping each other, especially because one of our goals was trying to check if this was possible. Even at a small scale, we were just 2, but we were trying to achieve that. So here are a couple of slides from our data layer. And in both cases, for the remote service and for the local service, we were able to write almost the same code. There are a couple of things that gave this out, like Kotlin or Swift. Here we have a name argument, but we could have changed that to it, to the keyword it. But basically, the similarities are there. And I want to be very specific about that. We were trying to achieve that because otherwise this code might look different. That actually happened to us. We were doing the same, but without enough communication. We were writing, using the same tool, the same language, some different code. So we're not saying that the same code, the same syntax is going to be always there, but it's easier to identify this if we communicate as a team. Well, in this case, we were grabbing from the API a list of strings and parsing the read from the URL with a substring, then building one of our data objects called dog, and then choosing a random element of this list to be selected. From the data source, we were grabbing the dictionary. The key value implementation was name and score. We needed to sort this by the score. So basically, we noticed that at a glance, the similarities are there. Obviously, as we walk towards the UI, the top parts of our architecture, these similarities are going to begin to fade. And although we didn't try to look for string similarities on our code, I remember reading an article that on the repository and on the data layers, it's around 80% when you are looking for it. I mean, when you're trying to write almost the same code, you can achieve like 80% string similarity between the two languages. But when you move forward to the view model or the presenter or whatever you're using, it reduces to 50. And of course, the last part is going to be almost completely different. And speaking of differences, we were at first looking only for similarities because we think it generates some value for both the developer and the team and eventually the business to be bilingual in Kotlin and Swift. But we noticed that there are several differences between the languages. We both, Cecilia and I, like roller coasters. The thrill of being a ride is incredible. But for some reason, we enjoy this in a different way. When we are doing the line, there are almost like really long lines for riding this at the amusement parks. Ceci is like jumping in excitement because we're about to get into the roller coaster, and I'm not. I'm quite frightened. My palms are sweaty. Sometimes I get dizzy, and I'm really suffering through the whole way until we get to the car, to the roller coaster car. Once I'm there, I just throw my hands in the air and I'm enjoying the whole ride, and let's just say Ceci it's not doing the same. Well, in this sense, both languages have several differences. The first one that we would like to share is the enums on Swift. These are quite powerful, are first-class types, and you can have almost everything that is also provided by a struct. And the idea here is that because we can handle state, it's common to see a pattern much similar to this code where you are returning a result enum handling both possible cases, the success and the failure. Unfortunately, in Kotlin, we have the Java enums that are not as powerful, but there are a couple of ways of handling this, especially the seal classes.
Yeah, like Adrian said, using enums in Swift are really, really powerful, and I wanted to try to achieve the same thing on Kotlin. And I was trying to collaborate with Adrian to figure out if there was something that was pretty similar to enums on Swift, and he mentioned these seal classes. Seal classes are classes that are able to maintain a state, and they're pretty much an extension of the enums. Seal classes allow you also to have subclasses in it as long as they are defined on the same class that you're, as long as it's defined on the seal class. And another thing that's pretty interesting is that you can also have only get attributes in the seal classes by adding the val keyword to that class. Structs is something widely used on Swift. In general, we use structs when we want to have immutability, and Kotlin doesn't have this. Whenever we use structs in Swift, and you pass it through a method or you define it on a variable, you're actually creating a copy of that, not object, but element. So if you're not careful how you handle this, then sometimes it has happened that you are building an application and you're trying to maintain state through a struct and you forget that it's value-based. Then whenever you try to figure out if the state is the correct one, you see that it's not the right one that you want because you decided to use a struct instead of a class. The structs, deciding to use whether to use a class or a struct for your data is a decision that's not trivial, and the results in the result in the implementation varies a lot. I don't know.
Well, something important here is that the decision that you make in Swift between a struct or another object is going to have a couple of drawbacks forward in the process. So it's really important to choose between a struct or an object. And in Kotlin, there are no structs, but we have data classes. The difference might not be obvious at first. At this talk, we're just trying to cover as much ground as possible, but there are several implications between data classes and structs, even if the end result is the same.
Yes, one common use of structs and data classes is whenever you're trying to consume data from an API, so you usually use some sort of, well, at least I use some sort of library to help me with networking, being Almafire or Retrofit, and you always kind of like need to map it to some sort of object. On Java, we used to have classes that were full of getters and setters, and they were like really huge, but with data classes in Kotlin, then that got really simpler, and with that definition, you already have the getters and setters that you need, depending on if you define it as val or var. And in Swift, we also use the structs for that specific same purpose, to parse the information that comes from the endpoint and have it as immutable, and that's something that we could use in the rest of the app. So these both classes are similar in some way, but different in terms of pass by reference or pass by value. Protocols is something that it's also really used a lot on iOS. At first, as I said, my main experience was Android. And on Android, I was used to having object-oriented programming, inheritance by creating classes and subclasses. And when I moved to the iOS side and started to watch protocols, because Apple promotes using protocol-oriented programming, it was really confusing for me, and I didn't see the value of it until I started to use it more and more and more. And now I see that the protocols are a great way to achieve composable objects and increase the functionality of things that I need, and to guarantee that some functionality is created as it's expected. Protocols in iOS are also kind of like first-class types. So you could also send protocols as parameters. You could send protocols as results, and you can use protocols in everywhere you want. This is one common use of protocols in iOS. It's to increase some functionality. In this case, it's the reuse identifier to be able to get a view controller from the UI, from the storyboard.
As protocols, something closely related to Swift, and even if we have interfaces in Kotlin, it's not going to be the same. Not exactly that, but something similar happens with coroutines. This is some topic that it's, for me, it's really interesting. I would like to ask everyone for a quick show of hands. How many of you are using coroutines right now in your apps? In production? Okay, still, it's a lot. Thank you. Well, coroutines have been around for a while as a concept. By the way, I don't know why this is not named with a K. That would be amazing. Coroutines. Kotlin? Coroutines? Okay. So anyway, if you haven't heard of this before, it's a non-blocking way of handling asynchronous code, but the code looks like it's synchronous. Instead of blocking the whole thing with a thread, stopping a thread, we're just suspending a function. Suspend, fun, but we want to have fun. Well, yeah, my bad puns are real terrible. So in this case, we're working with retrofit, and with the await keyword, this is going to suspend while we grab the data, and once everything is ready, we're going to check if it's successful, and then return the result. This is on our repository. In the view model, we're going to launch that coroutine using a special scope for this in order for the life cycle to be aware of whatever is happening with this asynchronous code. And because we're handling the UI, we need a special context. That's why we have a with context block in order to work with the main thread and handle the UI. Both dog list and current breed are mutable live data objects, and we're setting the value here. Coroutines have, in my opinion, have a bright future ahead, but although it's an old concept, we're still learning on how to implement this. And as a community, as the Android community, we are new to coroutines. So I'm hoping to see many new use cases and best practices to develop in the coming months. And there are a couple of other things that are not exactly part of the language, but are like in a middle point between the platform and the language, like Coin for dependency injection. The thing with Coin is that you don't need to learn how a coffee maker works, or deal with a pump and a thermosiphon, or all the things that are in the Dagger 2 sample. Dagger 2 is quite powerful. Dagger it's quite powerful, but Coin provides several ways and alternative ways to implement the dependency injection, and as easy as the code that you see here, it's all the dependency injection that we needed for our feature of the game. It even supports the view model, and this is all the module that we needed to specify in order to do the injection, and this is the injection itself. So Coin provides several advantages, and it's not that there are no other ways to do it, but this seems quite straightforward and has a small learning curve. Also, there's live data. In iOS, if you want to do data binding or a bind between the view model and the view, you need to use reactive extensions, either Reactive Cocoa or RxSwift or KVO. In Android, we have live data. And again, it's as easy as this. We're observing a live data object. And when it's changed, it triggers this event. So we update the UI. Both of these specific things made the whole process of working with this architecture in Android much, much easier. And to finish with these differences, there's also memory management. As we mentioned before, we're trying to cover a lot of ground here, so not much detail into this, but basically, Kotlin assumes that there's going to be a garbage collection, and Android works with concurrent mark sweep, so it traverses the whole object tree, marking which objects are being used and which not, and then sweeps all that are not being used. The thing is that it makes a pause, like holding everything for a second, preventing the allocation of new objects in order to check all the dynamic allocation on the heap. So with this approach, we have several drawbacks. One of them is that because it's grabbing everything that's not marked, the available space is going to be fragmented. So Android implements a compact mark sweep in order to defrag this and have all the available space together. But still, we're pausing everything. And if we have a lot of dynamic allocated objects in the heap, it's going to, our app is going to suffer. In Swift, working with iOS, we don't use this. Instead, we use automatic reference counting. It doesn't pause everything. There's only a counter to check how many times there's a reference for the object. But this might imply that a couple of cyclic references exist. With concurrent mark sweep, that doesn't happen. But with ARC, this is one of the many problems that it presents when working with it. And also, we depend more on the developer to understand how weak references work. In Android, we almost don't use weak references at all. So keep that in mind when dealing with the memory. So basically, those were our findings. And we would like to share a little bit of the lessons learned here. Still have like a couple of minutes to go. And experiments are fun. We really enjoy the process of doing this. Keep in mind that we didn't have a time constraint or a budget or even like many of those constraints that are present in our day-to-day job. And multi-platform, cross-platform, it's an interesting topic. I mean, back in 2010, we implemented several apps, and I'm not proud about this, using PhoneGap. This was way before Apache Cordova that, like, in some way, make things better, but still. Since that time, I've been a strong native development advocate, but 8 years later, we're still discussing this. And currently, at many conferences, there are many talks regarding this specific topic. I truly believe that becoming bilingual is something that can provide some value in different terms, even in natural language. I've been doing public speaking in English for a couple of years, and I'm still struggling with a couple of things like doing jokes. I mean, I can do terrible puns, but still, the audience is different. And although I think I'm able to communicate a point, it's not the same than doing public speaking in Spanish, but it has opened my way of thinking and understanding the community in different ways. The same thing happens with programming language, and especially with a couple of programming languages that are so similar, like Kotlin and Swift. It can broaden your perspective and easy the process to understand both platforms. Eventually, we end up developing some empathy for both teams working on these platforms. Keep in mind that the software is for people, developed by people.
So becoming bilingual requires commitment and trade-offs in order to reduce the overhead. We usually have kind of like an Android team and an iOS team, and each team has its own like style guidelines and its own way of building things. So in order to reduce the overhead to switch one person from one team to another one, we have to come to a place where there's trade-offs for each one of the platforms. It can either be on the style, how you write code, or on how you architecture your app. If there are no trade-offs in this, then it's probably, you could actually do it, but it's gonna take a little bit more of context switch whenever you try to switch one person from one team to another one. Also, that doesn't mean that you do not need platform experts. Of course, you always need persons who have a deep knowledge on one specific platform, but it also, having a bilingual team allows you to pull and reassign as needed. So probably, maybe on Android you have some technical dev that would require kind of like 2 or more developers that they're not available right now. But on iOS side, maybe there's like, we're kind of like maybe slacking off and we don't have a lot of work. So maybe you could actually pull one from the iOS team to the Android team if there's a pool of developers that are kind of like bilingual and understand both languages at some level. Also, bilingual understanding of the language can reduce implementation bugs. Sometimes you probably are implementing something in Android and you ask your iOS team, like, how do they implement it? And maybe they're doing something and they just give you a big, broad overview of how it's done, but you do not have kind of like the implementation details. And as a lot of persons say, like, the devil is in the details. So maybe they put it on the wrong lifecycle method, or they implement it in a different way, like they got the first one and not the last one. So being able to come to your teammates and say, okay, maybe you could look at this file, and actually understanding the code that the other person wrote could actually reduce the implementation bugs that you have in your code.
So going further in this road, there are a couple of options. I assume most of you, if not all, are Android developers working on Android apps. So if you really like Kotlin and Swift, you might look for a transpiler in order to work with Swift. I don't recommend this option that much, mostly because there are many differences in the language. So a transpiler will automatically translate the code from one platform to the other. There are several options. You can Google it or check it on GitHub. To my knowledge, all of them have several flaws in terms of lacking some implementations. So after doing the transpiling, you will still need to check the code manually. Instead of a transpiler, I would recommend to learn the other language. And even if you're not currently working on an iOS app, it's important to understand the platform as a whole. If you need or want to get into developing for both platforms, there are another couple of options. There are many actually, but I would like to recommend Flutter. Although it's quite new, I think it's promising, especially on the UI side. Working with widgets is interesting. The only thing is that it's going to switch your way of thinking, because architecting an app in Flutter, it's quite different. And of course, my heart is with Kotlin native. I really like Kotlin. And I think, again, as there is a long way ahead, Kotlin native is going to provide a way to implement cross-platform apps, working all the business logic in Kotlin and the specific on each platform natively. And for some reason, there are people advocating for Clutter, that's with a K, Flutter with Kotlin instead of Dart. To be honest, I don't really like that, but I think it works. So basically, these are the options that we would like to suggest on going further. I think we have 30 seconds to go. So in a nutshell, we did an experiment. It went good. We learned a lot. We shared a little bit of those learnings. And as I think we are running out of time, if you have any questions, we're going to be around the day, so feel free to grab us. And would you like to add anything else?
No.
No? Well, thank you very much.